how to convert a binary number to an octal number. In this tutorial, we will describe how to convert a binary number to an octal number. For example, let us convert the following. Okay, for this example, we're going to convert the value 10100101, which is in binary, to the octal value 245. Let's compute. Alright, so where do we begin when we want to convert a binary number to an octal number? One way to do this is to take the actual value. So let's kind of break this out a little further out. So we have 1, 0, 1, 0, 0, 1, 0, 1. And what we want to do is group the digits into groups of threes. So we'll take this group here and then take the next three. And because there's no 0 right in front of the 1, we'll go ahead and put a 0 there. And you'll take this group. And what we want to do is take each one of these groups and convert them to a value. So we have 101. This is, at this point, is still in binary. So we want to look at its position. So 0, the 1 here is in the 0th position. The 0 is in the first position. The 1 is in the second position. So we're only concerned with the values that are turned on. We say that we have 0 that represents off. If we have 1, that represents on. Alright, so for the value 101, the two digits that are on are these guys. So this position is saying 1 times 2 to the 0th power, and we want to add that to 2 to the 2nd power. So this gives us 4 plus 1 equals 5. And so this group of digits, actually this group's of binary digits, represents the value 5. And that'll be an octal. Okay, so let's look at the next group. The next group we have is 1, 0, 0. This is also in binary. And make sure up here it is 5. That's really an octal right there. So we also again look at the positions. We have the 0 here is in the 0th position. The next 0 is in the first position. And the 1 is in the second position. So we only care about this one since it's turned on. So we really have 2 to the 2nd power. And that's a value of 4 in octal. So that means that this group 100 represents the octal value of 4. Now let's look at the next group. We have 0, 1, 0. And of course that's in binary. This 0 here is in the 0th position. This 1 is in the first position. This 0 is in the second position. And we only care about this one since it's turned on. So what that represents, we just only have 2 to the 1st power. And so that represents an octal value of 2. And so this group represents the value 2. So we have 245, which is in the octal system, and this is what we wanted to show. So it matches this value. Now, as a test, what we want to do is convert this to decimal, just to show that that value is correct. How are we going to do it? Once again, let's look at the positions. Currently, 245 is in the octal system. So the 5 is in the 0th position. The 4 is in the first position. The 2 is in the second position. So what we do here, let's say we have a value of 2, and because we're dealing with the octal system, we say that we have 8 to the second power here because it's in the second position. We want to add 4 times 8 to the first power because we're dealing with the first position here. And next we want 5 times 8 to the 0th position. And let's compute. So we have 2 times 8 to the second power is 64. And then we have 4 times 8. And then we have 5 times 1, because anything to the 0th power is 1. So let's break it down. We have 2 times 64 is 128, plus 32, plus 5. And this comes out to be the value 165. And this is what we wanted to show. And keep in mind that this was a test. Next, let us perform another binary to octal conversion. This time we will convert numbers with a decimal point. How to convert a binary number to an octal. So once again, this time we have a value. We have the value 10001101.011, and that's represented in binary. And we want to show that this value is equal to 215.3 in octal. Once we convert that and show the value 215 in octal, we want to do a test just to see if we can convert it to decimal. There's some notes to the right that's going to come in to be handy, is since we're dealing with the octal system, we deal with a couple of positions. When we got 8 to the minus 1, that means that we're dealing with a digit that is 1 position to the right of the decimal point. So we have 8 to the minus 1 equals 1 over 8, and it will produce a value of 0.125. We have 8 to the minus 2 power, which is 1 over 8 to the second power, which is the same as 1 over 64, which is the value 0.015625. Let's compute. So we pretty much is going to do the same thing. So we want to break out this binary value, and we want to group them into threes. So we have the value, let's see, 1, 0, 0, 0, 1, 1, 0, 1, 0.011, and this represents the binary value. So starting from the decimal point, we have 3 digits, and we'll just group these into 3. And now we start looking at the values to the left of the decimal point. So the first group would be 101. The next one would be 001. And since we don't have a value here, you just throw 0 there, and that represents a group. So we have to compute each one of these. So we'll start off with the group to the right of the decimal point. So let's start. Let's start with 0, 1, 1. And of course this one is in the 0th position. The next one is in the first position. The 0 is in the second position. And we only care about the ones that are turned on, which are these two. So what we have is 2 to the first power, because that's in the first position. And we're going to add 2 to the 0th power, because the 1 is in the 0th position. So this comes out to be 2 plus 1, which equals the value 3. So 3 goes here. Now we look at the next group, 1, 0, 1. And so we have 2 to the 0, 2 to the 1, and 2 to the second power. These each define the positions. We only care about the values that are turned on. And in this case is this one. And also this value. So we add up 2 to the second power plus 2 to the 0th power. So we get the value 4 plus 1, and that equals 5. So 5 goes here. All right, the next group is obvious. We have 0, 0, 1. That's just 2 to the 0th power, which is a value of 1. So 1 goes here. And then the last group, we have 0, 1, 0. This is the 0th position. This is the first position. This is the second position. So we only care about the digit in the middle. So we have 2 to the first power equals a value 2. So 2 goes here. And don't forget the decimal point. So this represents the value 010001101.011 in binary is equal to 215.3 in octal. Now let's perform a test. And the test is want to show that we get a decimal value that's stated at the top. So we have this 5 is in the 0th position. The 1 is in the first position. The 2 is in the second position. Now the 3 is to the right of the decimal point, so it's in the -1 position. Okay, so let's compute and see if we can get to match the decimal value at the top. So we have 2 times 8 to the second power plus 1 times 8 to the first power plus 5 times 8 to the 0th power plus 3 times 8 to the -1 power. Let's break it down further. So this is the same as 2 times 64 plus 1 times 8 is 8 plus 5 times 1, because anything to the 0th power is 1. So we have 5 times 1, but 5 times 1 is just 5, so let's put 5 there. And then we have 3 times, and we say to the top corner here, we have 8 to the -1 power is a value 0.125. So that replaces here. All right, let's multiply it out. Still, we have 128 plus 8 plus 5, and 3 times, let's see, 3 times 0.125 is a value of 0.375. And so all this adds up to be, let's see, 128 plus 8 plus 5 plus 0.375. So it comes out to be the value 141.375. And this is in decimal. And this is what we wanted to show. This puts us in a position for my next tutorial, where we describe how to convert from hexadecimal numbers to decimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also, feel free to join us at the computing sector. There will be more videos and tutorials coming soon. Thanks.